Greetings and welcome. Last night we talked about the props of logs. And our homework was on page 615. Here's question 19. It asks, let's evaluate what log base 3 of 7/2 is. But they gave us some kind of like initial facts about some of these things. So for instance, what I would be able to do is log base 3 of 7/2. You might remember that the log of a quotient is equal to the difference of two logs. Right? And then I'd realize, oh, wait a minute, that's the 1.7712 they told me about, and that's the 0.6310 they told me about. And now I could just kind of subtract those 1.7712 because the quotient, or the log of a quotient is the difference of two logs. Property. Bam. 1.0. So it's just one of those properties you had to mesmerize.
So you just split it into two logs?
Yep. With a subtraction symbol.
Is it possible if we can buy a math card just to...
Sure, yep.
Okay, because I just want to write down like the...
Let's see, 23. This one's a little bit more interessante. So this is, I'm suspecting I'm going to rewrite 108 as the product of some numbers. So the first thing I'm going to do is actually break down 108. 108 breaks down into 2 and 54. 54 breaks down into 2 and 27. 27 is actually 3 cubed. So I could actually rewrite this as log base 3 of 2 squared, because there's 1, 2 right there, times 3 cubed, all right, is what I could break that into. And now we know that the log of a product is equal to the sum of two logs. So that's log base 3 of 2 squared plus log base 3 of 3 cubed. That's a lot of like, bless you.
Thanks.
Like 3's increasing in scale, 3, 3, 3, 3 sort of thing. The next thing we might know is that the power property of logarithms, that the log of a power, you can actually take that exponent and move it out front, write it as a product. Bless you once again. So what we'd have here is this is equal to 2 times log base 3 of 2 plus 3 times log base 3 of 3. And let's see, log base 3 of 2, we happen to know that value from up here. That was the 0.66310. So 2 of those. Plus 3 times, and now the question is, wait a minute, log base 3 of 3, that wasn't one of the facts they gave us. However, what that means is 3 to the what power is 3? And that's the first power, as E-Man Therian was saying for a long, long time. Because what log base 3 of 3 asks us is 3 to what power is 3, or 3 to what exponent is 3, and it's the first power. So being able to kind of imagine that in its exponential kind of question-asking form would be helpful. So let's see, 2 times 0.631 plus 3. I end up getting 4.2620 is the answer to this question. Which, what that means in the scope of the original problem, that means 3 to that decimal is 108. And actually, let's see if I could get that here. Whoa, jumbo calculadora. 3 to the second ants. So let's see, 3 to this decimal hopefully is 108 with a little change because we have some rounding error taking place there. So it does appear to work out. So that was using some of these properties of logarithms to kind of discover the values of other logarithms by combining some of the ones we already started with, sort of thing. Let's see, last question that we'll be going over right now, bless you, is, wow. Man, back-to-back sneezes. It was like a sneeze alley-oop right there. So let's see. The trick here is that if I can get a log equal to a log, we'll be in pretty good shape. So the trick here is I'm going to combine as a single logarithm on this side. as a single log. Right? And if I can do that, then I'll be in pretty good shape. So to combine this as a single logarithm, well, the 1/4 out front I can move as an exponent. The 1/2 out front I can move as an exponent. So I'll end up with this equal, or actually, sorry, there's already an equal sign here. This is an equation, my bad. So log base 10. Actually, guys, tell you what, log base 10, we don't have to write the base because 10 is the hobbit in the land of logs. So I could just write this as logi, not to be confused with Loki, the bad guy from Thor, equals log of 16 to the 1/4 plus log of 49 to the half. All right. Now it turns out 16 to the quarter, 49 to the half. Fractional exponents are the same as what? Radicals. So that's the same as the 4th root of 16 plus log of the square root of 49. So same thing still hanging out on the left. 4th root of 16, that is not 16 divided by 4. That is asking the question what number multiplied by itself, right? 4 factors, right, is 16. And that's 2. 2 times 2 times 2 times 2 is 16. So this is the same as log of 2 plus log of the square root of 49 is 7. Now, a moment ago, right up here, I said that, a little further down, I said that the log of a product is the sum of 2 logs. So working backwards, I could say that the sum of 2 logs is equal to the log of a product. So this is going to be the same as log of 2 times 7, or 14. Now check this out. I've got log y equals log 14. A log equal to a log. Their bases are the same. They're both invisible tens. Therefore, their ofs will be equal. So y is equal to 14. Ta-da. Now.
Wait, so you would add 2 and 7 and multiply them?
Yep. The sum of 2 logs is equal to the log of a product because that's what we had yesterday. That log base b of m times n was equal to log base b of m plus log base b of n. Well, it's kind of like symmetric to the property of exponents. So, for instance, if I said 2 to the 3rd times 2 to the 5th, you would have said that that's the same as 2 to the 3 plus 5, right? Or 2 to the 8th. Right, so the product of 2 exponents or powers is equal to kind of the power in which I added the exponents. Question, Jacob?
Yeah. Log y.
Yep.
Get the y.
That was the original problem. Yep.
No.
Yep. Now, just because I've got an answer doesn't mean it's right. It could be one of those demdare extraneous ones. So I do have to consider if I plugged this 14 into the original, I'm not doing a full check, just like a quick little mental check, would any of my insides of the logs be negative? And no, it wouldn't, so I think we're good. That's a good enough check for me. All right, so there's the idea, friends. Thanks for watching. Bye-bye.